Was that the tardy? Okay, so I'm going to visit our Canvas page really quick so that I can show you that the calendar there has been updated. So notice that it was, oh, how about you connect teacher to the screen? It was updated last week. So if you are wondering when you have quizzes and what is expected of you, remember, if I ever change anything, I put it right here on our home page. Yes? So I regret and am really reluctant to change your calendar after I give it to you, because now the calendar that you have, that your paper copy, is useless because it's different. But the good side of that is that I am willing to adjust what we're doing in class so that it best suits you. And when we need to go slow, then that means the calendar needs to be adjusted, which, has its downsides, but I think the good side is worth it. A couple of things that I want you to notice on our new calendar. So if you look at everything up to the end of Unit 4, there are no quizzes. Can you guys see that? So after changing the lesson format, I realized that for me, the questions at the end of each part of your lesson serve the same purpose as the quiz would. So if they serve the same purpose, I would rather you do what I personally think is the easier one, where you have unlimited tries to get 50 out of 50, and it's not a pressurized situation where you're timed and you only get one shot. That means, though, that you do need to complete them, and you need to complete them on time. So like all of this stuff that you were responsible for on Friday, that needs to be done, and I can see that it's done by going in and seeing if you did the lesson questions. See what I'm saying? So just know you have a new calendar. It tells you when we're doing anything. If our calendar changes, I will automatically change it on our homepage. No quizzes. Make sure you're getting the lesson questions done. Any confusion or clarifying questions for that? Okay, if you are, and not very many of you are in this situation, but the distance learners are, and they're listening to this. If you have an F or you're struggling right now with your grade, focus on all of the stuff coming up. We're not going to reopen quizzes and retake exams and do all of that stuff. Focus on your lesson, questions, and your exam coming up. If you need help with your grade, you need to come and talk to me. Don't send me an email that's 45 hours long. Just come talk to me. We'll figure it out. Okay, so that all being said, before we move on to today's lesson, are there any questions about residual plots? What you were supposed to do at home was graphing one residual plot by hand, which took 10 days, and then learning how to graph your residual plot in your calculator. So for those of you that did it, are there any lingering questions that you have? No? So you'll get some work time today. If you realize as you're going through you have questions, just stop me as I'm walking around. I should be out there with you guys walking around. Speaking of work time, if you go into our modules, our lesson is not there. Is that true? Try to be so prepared. Okay, so when we're ready to do those, it'll be there. I'll just copy it over really quick. I'm going to copy today's module over to our class. Please don't be doing the lesson while I'm teaching don't be doing the lesson questions while I'm teaching the lesson. That doesn't really It doesn't have the benefit that I think some of you guys think that it has. If you're half listening to the lesson and half doing questions, I'm not sure that that's the most that you can get out of this. So today's module has 2 parts. The first part is talking about 2 new ways to describe a relationship or to gain more understanding about a relationship between 2 quantitative variables. Then the other part is us revisiting this idea of influential points. So we've seen influential points before in a previous part of our unit, but we are going to talk about it today in relation to these 2 new things that we're learning. Okay, so the first thing that we are going to talk about is the coefficient of determination, and he is r squared. It is literally r times r. So let's remind ourselves what r is. R tells you the strength of your relationship. So if you need a reminder, maybe you should write it up here in the corner. R is strength and direction of relationship. So closer it gets to 1, the stronger the relationship is. This is also called the correlation coefficient, and sometimes it's just referred to as that, and it is not referred to as R. So in a problem, they might say the correlation coefficient is 0.65, and you need to know that correlation coefficient is the letter R. So now we have this thing that has a very similar name, that is the coefficient of determination. And this is one of my favorite things in this unit. This is one of my favorite things that describes a relationship. So it literally is R times R. It is always written as a percent. This portion is very important, so I shall underline. When you interpret R, you always interpret it as a percent. You'll probably get it as a decimal, but it will be interpreted, you will change that to a percent. Now, it's going to be a minute before we talk about this part again. So I want you to maybe make a little note that you're going to see this in your lesson questions. So maybe like circle it and star it so that you know that R squared is literally R times R. Okay, the cool thing to me about the coefficient of determination is that it tells you how much of the variation in your y variable is explained by your x variable. That's what goes in these blanks. It is the percent that describes how much of the variation in y is explained or described by x. So let me explain to you, or hopefully get a little clearer on what this word variation means in this context. So you can think about it as the difference in the Y values. You always want to use the word variation, but we want to think about it as the difference between the Y values. So what do I mean by that? We go into Auto Trader and we look at the prices of a bunch of different Ford F-150s. And we go in and we get all of these different prices for essentially the same truck, same model, same year, maybe a different color, but essentially it's the same thing. But all the prices are different. So how much of this variation or difference in our price is going to be explained by the miles driven? Does this make sense? So in this case, I would think, okay, well, there's probably a relationship there. Let me give you one where there wouldn't maybe be as strong of a relationship. How much of the difference in price has to do with how many owners the truck has had? Is that going to be as strong as the miles driven? Probably not, because when you go to buy a car, I don't think very many people, one, think to ask how many owners has this truck had, and two, if you're getting it from a dealership, which some do place ads in Auto Trader, they are not going to tell you how many previous owners it had. So we're talking about how much of whatever we have as our X variable will explain the difference in the Y variable. You feeling kind of okay about that? Okay, so they want us to do this for the attendance and test scores data, but I first want to look at it in this, and you don't have to go there, we can just use mine if you want, in this window. When we run the regression, notice that they give us the formula for the line, the y-intercept, the slope, and r, and we've kind of skipped over this r squared part right here. What this now means, this r squared, is that 66% of the variation in price is explained by the miles driven. Is that making sense? 66% of the difference in price can be explained by the miles driven. So how much cannot? If 66 can, how much cannot? 44? 34%? So that would make sense to me. That 34% would probably be things like condition of the car, right? Because if you got two cars that you're looking at and one of them has been owned by a smoker who looks like all they did for a living was chauffeur around dogs, you're going to be paying a lot of money for that truck if you have one that's clean? No. So it makes sense to me that this percentage is a little bit lower. I think 66% is kind of low, but it would make sense to me because there are other factors when you are buying a car. Like, it is almost impossible to get dog smell out of a car. I owned a car once. It was a horrible experience, Daniel. Thought I was going to be able to shampoo out the dog smell. Never happened. Never happened. Eventually I wrecked it. Not on purpose, but I was glad to get rid of the dog smell. So I do think that it makes sense that other factors will play into the price of your car. Okay, so now let's look at this specifically in terms of our attendance and test scores. So we've been talking about this data set for a while too, where we're looking at percent of days attended to describe an end of year test score. Now, the last time we looked at this data was when you had to make the residual plot for your calculator or in using your calculator. So for me, this data is still in my calculator. I'm gonna remind myself what list it is in. Mine is in 4 and 5. So I'm gonna run the regression on this for us to get our R squared value. So I'm gonna do stat calc 8. My list is already in. And this gives me my R and r squared. So this problem wants us to interpret r squared for our attendance data. So let's do that now. We have an r squared of, and I'm not going to round it here, I'm just going to write it all out, just for my own purposes. If you want to round now, you can. 903,429,0211. If we're going to round this, what would we round to in terms of percent? 0.9 what? 0. Before we interpret, I just want to show you that this really is r squared. So notice our r is 0.95. If I do 0.95 squared, I do get 0.90. Is this making sense? Anybody know why I put parentheses around the 0.95? So it squares the whole thing, which in this case wouldn't make a difference, but it would if this correlation were negative. So it is possible to have a negative 0.95 relationship, because remember, it's strength and direction. So the negative is telling us it literally is going down and it is a strong relationship. If I square this, I get negative 90%. Is a negative 90% possible? No. The variation in y that is explained by x is not negative, it's a percent. So it doesn't matter for the percent if your relationship is positive or negative. You describe that using r, not r squared. Okay, so back to business. Now we interpret. So remember, we talked about it for 2 seconds, and now we got to go back to it. Always write it as a percent. So we start with 90% of the variation. And we always use that word. In the, and then I'm going to remind us of what our response variable was. Our response variable was the end of year Algebra 1 exam score. Now, let's get a little bit real here. This is a very extra description of the response variable. So in real time on a test, especially your AP test that is timed, if you wanted to cut that down to just exam score, you could without any penalty. So 90% of the variation in the exam score can be explained by the number of days attended. Now that could be shortened down to attendance. So let me read that fluidly before we fill in that last blank. 90% of the variation, or 90% of the difference in the scores, can be explained by attendance. The last blank is when we use the LSRL, which we have not talked about yet. It is our next lesson. So if I lift up this page, you can see that our next lesson is the LSRL. It's nothing new. This is the same regression line that we have been working with. The explanation for it, though, is a little bit complicated. It's very heavy in mathematical reasoning. So I usually push it toward the end of the unit rather than at the beginning of the unit. But this line is the same line that we've been using for a few lessons now. Then below, you just have, oh, I forgot this little part. He's an important guy. So we've already talked about this idea. If 90% of the variation in exam score can be explained by attendance, that means that 10% of the variation is due to other variables, or 10% of the variation is not explained by attendance. Let me tell you why this is in, and I'm gonna write a little star next to it that says like test or quiz. My pencil fell. So last year's test for this unit had a question that says there is a relationship that has a correlation coefficient of 0.85. How much of the variation in Y cannot be explained by X? And what happened was most of the kids stopped reading and found R squared, when what they needed to find was the opposite of R squared. Does that make sense what I'm saying? So be careful when you read your questions, because sometimes they're going to sneak it in and ask you how much cannot be explained, and we're going to be so used to questions asking us how much can be explained. So be on the lookout for that. I meant to say test or quiz, not test score. Okay, so that is R squared. There's really nothing more to R squared. The most important thing about it is the understanding and the remembering how to interpret it. The one other descriptor that we are learning today is the letter S, and it is the standard deviation of the residuals. This is the other thing that I really like in this unit. I think that these two are my favorite descriptors. So previously, we defined standard deviation as the typical distance from the mean to each data point, typical or average. And we want data sets that have a small standard deviation, because that means that our data is clustered together and reliable. The more spread out your data is, the less reliable it is. So we want small standard deviation. Standard deviation tells us about how far away from the center are our observations. So then what is standard deviation of the residuals? Well, the standard deviation of the residuals gives us the approximate size of a typical prediction error. So essentially what S tells us is, by about how much will our predictions be off by? By about how much will our predictions be off by? So when we predict price, by about how much will our price be off from the actual price of a Ford F-150? That's what S is going to tell us. So that, in other words, that means it's the typical distance between the actual Y value and the predicted Y value. So one thing to know before we interpret, you will always be given S. Our calculator does not calculate S for us. So if you get a problem where it's going to ask you to interpret S, they will always give it to you. So here, that's exactly what they do. Recall for the Ford truck example, or recall that example. S for this example is $5,740. Interpret that standard deviation. So this is our phrases to memorize. This is how we usually say it. Our predictions will be, our predictions will typically be off by about $5,740 from the actual price of a Ford F-150 when we use the LSRL. So our predictions on average will be off by about $5,700. So once again, we want a very small S. We want a very small standard deviation of the residuals. If we go back to the price that we predicted, so we predicted for 80,000 and we were off by 4,500, that is within that S. So sometimes you'll be off by a little bit and sometimes you'll be off by a lot. Sometimes you'll be over, sometimes you'll be under, but on average, you will be within about $5,700 of the actual price. Do you feel okay about that? Was that a yes? Okay, I want to highlight a couple of things before you practice this in the module. There's only a couple of questions on this. For your phrases to memorize, make sure that you know you always write R as a %. Then down here, make sure that you use the word typically and that whatever S is, you include the units. So if I were interpreting S for the test score data and S was like 2.5, I would say our predictions will typically be off by about 2.5 points from the actual test score. You're okay? Okay. So it will take me just a second to move your module to the top, but once it's there, I want you to practice the couple of problems that are in there. And if you want to redo it so that you have 50 out of 50, you can, there's like 99 tries.